All right, so we have a complete off-bow tower. So during the quiz, eventually, I'm going to have a typed-up mini version of this for you to use. But pause the video and copy your own version down. Do your best as much as you can to try to make this kind of boxy, or think of it kind of like in a grid. It'll help just a little bit for what we have to do with it. But go ahead and pause for that. There you go. Pause for my cough. Okay. So here's the shocking thing about this. First, it's a nice reminder that even though every Pell has an S, which is nothing special, the other ones don't, and they kick in at, well, very predictable times. So notice there is no such thing as a 1P, right? Our P's start on Pell 2 because the shape is too much energy. And D start on 3, which, if you recall, was one of the oddities for our periodic table, was even though we're on Pell 4, for Scandium, we call this 3D1. So part of the oddness for the periodic table is they have the off-bow built into this shape. It's just a little unintuitive for what we would kind of expect to roll with. Okay, so here's what this does for you. Because I know you're looking at it and saying, yes, I can count the 3's together, and I know it goes S, P, D, F in that order. True. But the way you read the off-bow tower is not top to bottom, left to right. So you're not reading it like this. Or at least you're not supposed to. What you're actually going to do is we're going to follow reverse diagonals. I know, you did not see that coming. Okay, let that fade out of the way. So here's the idea. On your awesome one that I know you've drawn in the notes, right? You're going to draw diagonal arrows coming down at the letters. If there's a letter on the other side of it, you will continue to arrow through. But if there's a number, you stop. Okay. This might beg some questions for like, hey, why? Here's the extreme coolness about this is it coincidentally gives you the exact pattern of what energies come first. So if off-bow is all about order, this is how you know what suborbital comes next. If you go, okay, I've filled everything that I got, I'm following the principle, but you need more, go to the tower. That's how you know what comes next. So order, start with a 1S. Following that, 2S. Notice there was no letter on the other side of the S, so I picked up and started a new arrow. Okay, after the 2S, we'll start on 2P, but there is a letter on the other side of P, so it cuts through. Now at this point, if you're counting the order, that's 1S, 2S, 2P, 3S. Super non-special, everything you would have already known and guessed. Okay, but do the next arrow. When you pick up for a 3P, you don't go to 3D, 4S comes next. So we de facto reasoned that a 4S must be lower energy than a 3D. And one of the ways we can say is, okay, following this on the off-bow principle, the 4S will fill first before the 3D. So just think of the goofiness of that, right? I'm not going to do the whole thing, but okay, you're in the 3D. You're in the third Pell. You have a 3D, but you go out to the 4th level before you go back in and make the 4-leaf clover show up. So the weird thing is that we start finding is these electrons will skip levels very, very dramatically. To the extent that if we draw a couple more arrows on our system, it's going to be much goofier. Like literally just do the next 2 lines. Okay. So after a 4S is 3D, then a 4P, then a 5S. So realize we just went Pell 3, Pell 4, Pell 5. And we get the same effect, 4D, 5P, 6S, to the extreme when we pick up the 4F arrow. Okay, so this is the last one. I'm not going to make us walk all the way through it. But after 4F is a 5D, followed by a 6P and a 7S. We cross 4 different pels. So our first analogy, when you kind of think of the off-bow, is it's electrons that we're dumping on top of the tower, and when we fill up one, it spills over to the next, and then to the next with 3 different shapes of P's, and then that spills to the next. Okay, that's not wrong necessarily, but rather than thinking of this as just a bunch of buckets stacked, it's going to jump around and sprinkle into different sizes in unpredictable ways. But very fortunately, you've just drawn a series of arrows that will predict all of that. I'm going to give you the tower blank, though, so you have to be able to pull the order off of the tower. Just as a brief practice here, we're going to do a quick, to see if you can read this okay. All right, so just going to do some rapid fire ones here. And hopefully you can answer this as quickly as I'm typing them. Okay, moment of truth. So following 3P takes us to the 4S. Okay. After 4D, you follow on to a 5P. Cool. Okay. From 5F, I didn't even draw the arrow for this one. This one comes on to 6D. Very nice. And lastly, go a little chartreuse here. After that, 6D takes us to a 7P. Sweet. Meaning, if we have to fill an order, order is lowest energy gets filled first. The tower is how you know what comes next. More importantly, more realistically, you can get a real sense of when somebody screws up the off-bow principle. So one of the things eventually I'm going to ask you to do is to correct faulty configurations. All right, so watch this. Okay. This should read really wrong, like super cringy. We have no idea what this person was going for. Welcome to my hell on certain quizzes, right? Okay, so here's what I need you to do, and this is something I'll ask you to do on a quiz. I'll give you a really messed up electron configuration. And knowing the rules, of which we only know off-bow so far, I need you to point out what's wrong with it. Don't try to fix it, because realistically, we have no idea what they're going for. Like, I don't even know if the electron total is the correct one. So, you are looking for where they went wrong. I'm not going to tell you how many, but go ahead and pause and see what you think. Okay. Just because these get potentially a little explaining, I'll go ahead and type them out here for us. A place that we can read. Fantastic. Okay. First one, as you're reading it left to right, I have to say it must completely fill a suborbital before moving on, meaning that 2s1 needs to be a 2s2 before you would even tap back into the tower and unlock the next one. You have to fill that up. Okay, so that's one mistake we can talk about fixing. Yeah, this guy. Okay, cool. From there, arguably, I'm going to say there's 2 other mistakes. This guy, and something's missing. Okay. So one of them, 2D does not exist. So this would have been the same if I tried to trip you up with a 1p. So if off-bow designates which suborbitals are permissible and where they are, adding one that does not exist kind of breaks that rule. Okay, here's the other one. Cannot skip suborbitals, meaning they need to pop in a 3s before they start talking 3p. Totally true. Okay, cool. As we pick up the other rules, they are a little bit quicker. There's only so much we can do with them, which is a good thing. Which says, hey, we should talk about the other rules. Okay. Following the off-bow principle is something you have been doing for a long time. We just haven't really paid it much mind yet. But this is something referred to as the, let's see if we can figure out how to underline this. Sure, be italicized, that's fine. Called the Pauli exclusion principle. Got a lot of principles. Notice the PLEs because these are rules, not fundamental basics. Okay, so here's the idea. And I think a good example of this is something that you would freak out to immediately. Okay, so I'm just going to say, hey, here's an example. If I say 1s3, immediately you should flip the table and say, you can't do that, with great indignation, because you are citing the Pauli exclusion principle. Okay, because what is the error? This is all about max of 2 electrons per suborbital. Realize if you feel like we're breaking something because we're saying P's have 6 and D's have 10, realize this is per shape of suborbital, right? So there's only one S shape, so that you can only truly hold 2 there. So breaking the Pauli exclusion principle, we went over the cap. If we go into the why of it, so here's the idea. Let's say if we take 3 electrons that are all the same energy, and we try to force them into the same space. Remember, they create the shape. So if we try to force them to exist into this space and they start blinking around and doing their thing, so they're all the same energy, all in the same PEL, by merit of the fact that they have negatives, and that creates a certain field, and all them negatives love to repel, that means one of these guys is pushed out of the PEL, or, well, suborbital in this case, and is forced to create its own shape. So if we say, hey, why are we capped? It's a combination of repulsion and the fact that you have to maintain the same energy. And realistically, when you get pushed out of a suborbital, you do gain a little bit of energy with that, and that creates the next shape. All right, a little bit of cleanup. This last one is the fun one. And I say that with only mild sarcasm. I got to show you how to do something completely different for it. Now, this is Hund's rule. Notice it's not even a principle, it's a rule now. I know. Big deal, huh? Okay. So here's the weird thing. Based on all of the awesome electron configuration stuff you already know how to do, writing the code, even by endings and identifying elements, and being able to use the off-bow and essentially knowing everyone in order always, and being able to fix mistakes, and Pauli caps at 2. Okay. Hund's rule would not be seen in any of these circumstances. It's kind of goofy. Because if we say that, off-bow is about order. Pauli is about max. Hund's rule is about spins. Pray tell what spins, you might ask. Fair question. We haven't talked about this. So, here we go. Hund's rule creates a whole new system of skill that is essentially, how do you show your work when your answer is 1s2, 2s2, 2p4. How do you show your work for that? Okay. Coincidentally,